in the last video, I sort of basically presented, well, actually in the last two videos, I showed you the, I guess you could say, power of physics, and how, yes, it is very scary, and it's most likely because physics is an almost all-encompassing science. It's everything around you, and it can be hard to take it all in at once, especially when you're trying to understand something specific. Now, let me sort of take an example of, say, you're playing catch with a friend. Now, you want to sort of understand the motion of a baseball. Now, you throw the ball to your partner that you're playing catch with, and like I said, you want to understand the motion of the ball. Well, the way how your house looks, or the way how, say, any environment that you're in, it doesn't have anything to do with the motion of the ball. Now, if you're underwater, then yes. But in normal situations where, say, you just want to understand the path of a ball, regardless of air resistance, or if you're underwater, I guess you could say the resistance of water against the ball, that's rendered inexistent, and it's negligible. So you basically create a model to simplify these situations. So you take out everything not having to do with the path or motion of the baseball, and so that you can isolate a specific system, which is, you start out at point A, you throw the ball goes on a parabolic path. Let me actually draw this out. What am I doing? I am not utilizing my my Bamboo Connect drawing pad. So you have the ball here, say at point A, and then let's just say, and it's taking let's just say this ball is traveling very fast and it doesn't really have a parabolic path, and the person here is crouching down, and it's caught in this glove right over here, and this is point B. So you just want to isolate that. Wow, that really looks like Pac-Man over there. But whatever, it's a glove. So what you have done is you have made a system by drawing a model of a specific situation. So by creating this simple model without fancy drawings, you are able to understand the motion of the baseball. And you will actually find that this, a lot of physics is an applied science, but you will find that all of these models and systems that help to simplify a situation correlate rather nicely to what we call and all know as the scientific method. Now, if your school requires you, or rather allows you to enter into a science fair, there are certain steps you must take to doing the scientific method correctly. Now, the scientific method, since a lot of the sciences, including physics, are difficult to describe, you want to isolate specific situations to understand a certain part of that science. So to help do this, there are the steps of 1, observation, and collection of preliminary data to form a specific sort of thesis statement. If you are into English and writing, you will know what a thesis statement is. It's basically a statement of an if and then, like if this happens if I change this, which is the independent variable. An independent variable represents, independent variable change, and the dependent variable is something that you measure. So you measure that change. Measure. There we go. So you can actually see why these variables are named respectively for how these relate to each other. The dependent variable, since it's measured because there's a change in the independent variable, that's why it's called dependent, because the dependent variable is dependent on whatever the independent variable is changing. So that is what a hypothesis is. It's an if-then statement, hypothesis, that helps to describe a specific situation. Now, after you are done stating what you think will happen, you then experiment. Now, some people might use the term controlled experiment, and basically what a controlled experiment is, a controlled experiment is it has a control, which is basically a controlled variable added to the independent and dependent variable. It's basically keeping the environment the same. So keeping environment the same. Now, the reason why we have to do this is because we have taken, since we have simplified, say, this baseball example right here, since we have simplified that and taken out every single thing that does not have to do with this motion, we have to be careful. We don't want to change anything outside of this environment that actually does affect this parabolic path or the motion of the ball. So we need to have a control. We need to keep the environment the same, or anything else that would in any other case affect the motion of the ball. Now, since we are measuring things, we have to have results. Now, after we have the results, we have to figure out whether they do match our hypothesis. Now, if they don't, or if something is wrong with our results, we can always revise our hypothesis and then go through another experiment and come up with a set of results that do match what our hypothesis stated, our revised hypothesis stated. Now, once we have our results, we can then conclude something. So we come to the conclusion. Now, the thing about the conclusion is, if you are concluding something, you are basically saying that if someone else other than you performs this experiment that you have carried out, if they perform the same exact procedure with the same exact materials, it will perform a similar, if not the same result. If it is not verified, if the conclusion cannot verify that someone else can do it with can perform this experiment with the same results, then this hypothesis cannot be validated. So, but once the hypothesis is validated, we can then use that hypothesis, which could become an equation or a theorem, to predict new situations such as this. And that is a major part of physics and all of the other applied sciences to which we study today. Now, I hope this is sort of a good, I wanted to make this video to kind of let you know how the structure of physics is and why why the scientific method is so heavily embedded into physics, because, well, it helped create the text from which I am reading right now, and which you might be reading from right now as well. Anyway, I will in the next video I will go over units and the significant figures. Have a nice night.